Hello students. Earlier we saw the Mendeleev periodic table. Okay, the Mendeleev periodic table, you know that it is based on the arrangement of elements in the increasing order of their atomic weight, which is also called your atomic mass. Okay, so the Mendeleev periodic table, the elements are arranged in the increasing order of their atomic mass, and we saw that the Mendeleev periodic table had so many drawbacks. Yes, like for example the isotopes. Okay, the placement of isotope, we could not place the isotopes in the periodic table. We could see that similar types of elements, they were not placed in the same group like that. Yes, so because of the drawbacks of Mendeleev periodic table, this periodic table was discarded. Okay, and after that came modern periodic table. Now the modern periodic table is the periodic table we see today. Yes, you have seen the periodic table chart. Yes, so the modern periodic table, it is based on the arrangement of elements in the increasing order of atomic number. Atomic number, you know that it is represented by the letter Z. An atomic number is the number of protons or the number of electrons in a neutral atom. Yes. So in the modern periodic table, elements are arranged in the increasing order of atomic number. Very important, this one. Okay. Now, there was a scientist called Moseley. Okay, based on his findings and experiments, he found out that the fundamental properties of element, it was atomic number and not mass number. Okay, atomic number, it was the fundamental property of elements, meaning it was the characteristic property of elements. Each element has had its own atomic number. Yes, like no two elements, you know that, no, have the same atomic number. So atomic number was a characteristic property, was a fundamental property. So he suggested, why not arrange the elements in the increasing order of this fundamental property, which is your atomic number. So they arranged the elements in the increasing order of atomic number and gave the modern periodic table. So this is the modern periodic table, also called the long form of periodic table. As you can see out here, the elements are arranged in the increasing order of atomic number. Hydrogen has 1, then helium 2, 3, 4, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Yes, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, and so on. Yes, so this is your modern periodic table. Okay, the modern periodic table is based on the law which is called modern periodic law. Now let's see what is it. The modern periodic law says that the physical and chemical properties are the periodic function of their atomic number. Okay, it means that when we arrange the elements in the increasing order of their atomic number, then similar type of physical and chemical properties will occur after regular interval. Okay, that is the meaning of periodic function. Same type of physical and chemical properties will reoccur after certain intervals. Okay, and the reason for this periodicity, that is the reoccurrence of similar chemical and physical property, is here. Reoccurrence of similar electronic configuration. Okay, because same type of electronic configuration will reoccur after certain interval. That is why similar physical and chemical properties will reoccur, will be repeated after regular interval. Like for example, now have a look. So we have arranged the elements out here in the increasing order of their atomic number. You see out here 3, 4, 5, 6, 7, 8. Then again at 11. Okay. The properties, the chemical and physical properties of lithium, sodium, potassium will be similar. Yes, after certain intervals, same type of properties they are showing. Why? The reason is because of the same electronic configuration of these. Like for example, lithium if you take. Okay, so lithium you are taking, it is atomic number is 3, so it will be 1s2, 2s1. You take sodium, 11. Okay, 11. It will be 1s2, 2s2, 2p6, 3s1. Yes, again if you take potassium, 19. Yes, it is here 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Yes. So have a look. What is happening here? 2s1, s1, s1, s1. Same type of electronic configuration reoccurs after a certain interval. That is why, have a look. If they have similar electronic configuration, they will have similar properties. Okay, that is the reason for showing similar properties. Like for example, here also, valency is 1, valency is 1, valency is 1. So they will show a similar type of chemical reactions. Yes. So just keep in mind this one. Okay, the reason for cause of periodicity is because of the reoccurrence of similar electronic configuration. Okay, now let's see. The modern periodic table consists of, you know that they are divided into periods and groups. Okay, the periods are horizontal rows and the groups are vertical columns. Okay, so let's see here. So periods, the periodic table is divided into periods and groups. Okay, keep it very clear in your mind. The period is the horizontal rows. Okay, horizontal rows are called periods. Okay, how many periods are there? 1, 2, 3, 4, 5, 6, 7. 7 periods are there. Okay, and you should know that the periods represent the number of shells. Number of shells, you know that, no? N, principal quantum number. Okay, so out here for the first period, out here elements present in the first period will have only one shell. Elements of the second period will have 2 shells, K and L. Third one will have K, L, M, 3 shells. Fourth, K, L, M, N. Yes, 4 shells, like that. Okay, so that is your periods. Then the groups. The vertical columns are called groups. Okay, and how many groups are there? There are 18 groups. Okay, so the newest representation of the groups will be 1, 2, 3, 4, 5, 6, 7, and 9, 18. Till 18 is there. Earlier there were subgroups as well, A and B. Okay, 1A, 1B and all. Okay, you check in the book. Alright, but here now accepted one is this one. Okay, the newest accepted one is 1 to 18. So there are 18 groups written as 1, 2, 3 like this. Okay, 18. Now here the groups. Okay, if you take the elements of a group, they will have the same electronic configuration. Okay, the elements of a particular group will have the same electronic configuration. Elements of a particular period will have the same number of shells. That is principal quantum number. Okay, and out here, here period 1. Okay, there are 2 elements as you can see out here. Period 1, 2 elements. Yes, period 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Third also 8 elements. Okay, so that is why period 1 is called very short period 1. It has just 2. Okay, period 2 and 3, they are called short periods. Then number 4 from here, it will have 18 if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18, this will also have 18. Okay, they are called long periods. And here, number 6. Okay, number 6 here, have a look. 55, 56, 57, then 58 and all missing out here. No, after that we have 72. So after 57 is 58 out here. 58 till 71, then we go back out here. Okay, so if you count 18 out here plus this one, okay, it will have 32. Okay, 32 elements. So 18 out here, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 elements. Okay, then again 7, 87, 88, 89, then we go 90. Okay, now 32 elements. Okay, so and these 2 periods 6 and 7, remember they have got 32, so they are also called very long periods. Okay, short periods, long periods, and very long periods. Okay, so I want you to refer your book here. Have a look why they have got 2, 18 and all. So in the first shell, okay, in the first period, there are only 2 elements. Yes, so filling of S subshell only is required. S will have 2 electrons, so 2 electrons, so that is why 2 elements there. Then in the second, the filling will occur from 2s to 2p, so S will be 2 plus p will have 6 electrons. 2 plus 6, 8, so 8 elements. Out here in the third period, filling of 3s and 3p. S has got 2, P has got 6. So 2 plus 6, 8. Okay, then fourth will have S, then D orbital will also come, then P. So S will have how many? 2. D will have 10. 12, then P will have 6. Total is 18 electrons. Okay, so they will have 18 elements. Then from the sixth one, it will have S, P, F and D. S is 2. This one, P is 6. F is 14 and D is 10. Total is 32. Okay, so those are the number of elements in the different periods. Okay, then groups, you saw that they will have the same electronic configuration. Okay, then some important groups, the names I want you to remember. Okay, here. Group 1. Can you see group 1? Okay. These are called alkali metals. These are called alkali metals. You know that, no? You have done in class 10 also. That's why I'm doing it in brief. Okay, because you have done in class 10 also. Then this one, group 2 is called alkaline earth metals. Okay, group 2 is called alkaline earth metals. Then the next one, coinage metals, is group 11. Have a look, this one. Group 11, there is copper, Ag is silver, Au is gold. These are called coinage metals. Okay, they are called coinage metals because earlier they were used for the making of coins. You have heard in the history, yes, in history, there were copper coins, gold coins, silver coins and all. Okay, so that is why they are called coinage metals. Okay, the next name you have to remember is this one, for nitrogen family. See, can you see group 15, nitrogen family, they are called nicogens. Okay, P is there, P silent, nicogens. And group 16, this is oxygen family, they are called chalcogens. Chalcogens, remember the name. And 17, this one, fluorine, chlorine, you know, they are called halogens. Yes, they are called halogens. Group 17 is halogen. Then finally group 18, these are the inert gases. Okay, noble gases. They do not like to react with other elements. They are called halogen. They are called noble gases, or also called the inert gases. Okay, group 18 are called the inert gases. I want you to remember the names. Okay, then after that we go to the blocks. Okay, the periodic table is divided into 4 blocks. Okay, 4 blocks depending upon the different subshell here. You have got S subshell, P subshell, D subshell and F subshell. Yes, so we have got 4 blocks, S, P, D and F. S block, P block, D block and F block. Okay, so if you look at the S block, these elements will have the last electron entering the S subshell. Okay, similarly P will have the last electron entering the P subshell, D will have the last electron entering the D subshell and F will have the last electron entering the F subshell. Okay, that is how you remember. Now I'll show you where are the blocks. Okay, now the blocks, have a look here. This one, can you see out here? The blue one, this is S block. S block. Okay, now out here, this portion is your P block. Okay, P block. Then in between here, pink one, can you see pink one? This is called the D block elements. D block. Then finally down, the addition here, this is called the F block elements. Okay, yes, period is 6 and 7. Okay, this is called the F block elements. So S, P, D and F. These are the different blocks. Okay. Now let's see the S block. So these elements in which the last electron enters into S subshell, I told you already, of the outermost main energy level, S subshell of the outermost shell. Okay, so the general configuration for this one would be NS1 to 2. Okay, S will have only either 1 or 2 electrons, yes or no? So out here NS1 to 2. Okay, so have a look. The example here given is sodium and calcium. Sodium, have a look here. Calcium, this one, S block. Yes, so if you look at the electronic configuration of NS, if you write it, it will be 1s2, 2s2, 2p6, 3s1. Yes, 3s1. Now general was NS1 to 2. So last one, which one is it? 3s. Value of N for here is 3s and 1 electron in S. Yes. Then calcium. If you find out 20, it will be like this. 1s2, 2s2, 2p, 3s, 3p. And have a look at the last one. Last electron enters the S subshell. Yes. And value of N out here is 4s2. Okay. 1 or 2. Got it? Okay, this is S block. Then we go to the P block. These elements, the last electron enter into P subshell of the outermost. P subshell of the outermost. Here also S subshell of the outermost main energy level. Here as you can see, outermost is 3. So enters the S of the outermost. Okay. Then here the electronic configuration would be NH2 NP 1 to 6. Okay. So if you take chlorine and oxygen, chlorine, have a look, here it is. This is P block, yes. Oxygen I have taken this one. Okay, chlorine is 17. Chlorine 17, if I find out the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. Okay, so have a look. Outermost shell is what? 3. Yes, have a look. 3s2, 3p5. NS. N value out here is, N out here is 3. Yes. NH2, NP5, 1 to 6, here it is, no? So we have got 5 electrons. I hope you are getting it, this one, no? If you take oxygen, 1s2, 2s2, 2p. Okay, outermost is which one? 2. So here, value of N is 2. Yes? So, N here, NS2, S is completely filled, P is 4. 1 to 6, it can be 4. Yes, that is P block. Okay. Then we have got the D block elements. So these elements, last electron enters the D subshell. Yes, I told you earlier, but you have to remember out here, D subshell of the outermost. No, for the penultimate main energy level. Now this penultimate means, you know the outermost, yes, outermost shell. Okay, so I have got out here, this is the nucleus. Suppose I have 3 shells. Okay, this is called the outermost, which is also called the valence shell. Then one step inner to the outermost, that is called your penultimate. This is your penultimate shell. Okay, if the outermost shell is N, penultimate shell is 1 less than N. This is the meaning of penultimate, second last shell. Understood? Penultimate, penultimate. So here D subshell of which one? Penultimate energy level. Okay. And the general electron configuration would be N minus 1 D. Can you see out here? This is N minus 1. Penultimate. N outermost. So D can have 1 to 10 and NS outermost can have 1 to 2 electron in S. Okay. For example, iron 26. Iron, have a look. This is D block, I told you, pink one. Iron is 26. Can you see 26 out here? So let's see the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6 is there. Yes. So out here, outermost highest is 4. Yes. 4. N value is 4. Okay. Out here it can have 1 or 2. We have got 2 electrons. Yes. Then N minus 1. N minus 1. 4 minus 1 equals to 3. Yes, 3d6. So it has got 6. General, it can have 1 to 10. Okay, 3d6. Okay, last electron enters the D subshell of the penultimate main energy level. Got it? Now out here, if you take scandium 21, you get this 4s2 3d1. Yes, 4s2 3d1. Now for chromium, have a look. You know chromium will have exceptional configuration. Yes, expected is 4s2 3d4. But because this is more stable, this configuration is more stable. So it will have 4s1 3d5. 1 electron from S will go to D to make both half filled. Exactly half filled. You remember you did earlier. Yes or no? So it will have a look. Outermost is 4 is N. 1 to 2. Yes, so it has 1 and D, it has got 4. Got it? And finally, F block. These elements in which the last electron enters into the F subshell, okay, of anti-penultimate main energy level. Anti-penultimate is this one, okay. This is second last, penultimate. One step inside, this is called anti-penultimate shell. Okay, this is outermost is n, minus 2 is your anti-penultimate shell. Okay, I hope you understood. Yes, outermost is n valence, then one step inside, that is called penultimate shell, second last. Third last, it is called anti-penultimate shell, n minus 2. So the F subshell enters the anti-penultimate main energy level. Okay, so in general configuration, it is n minus 2 F can have 1 to 14, n minus 1 D can have 0 to 1, ns2. Okay, so out here anti-penultimate. Okay, this is penultimate, this is outermost. Okay, so you have taken the example of cerium 58. Cerium is this one, F block. Yes, and I hope you remember the sixth one out here in the F block. This is called lanthanides, and down one are called actinides. Yes, okay, so if you do the configuration, you'll see this one. Yes, 6s2 4f2. Okay, so have a look. 6s2, outermost n is 6 out here, then this is F, no, n minus 2 is 4. Have a look, 4f2, it can have 1 to 14, and D, it does not have anything. So can you see 5D? Okay, 5D, it will have 0. Okay, 5D can have 0 or 1. 5D out here is 0. Okay, so that is it. Then after that, you have got 4 classes of elements. Okay, the 4 classes would be inert gases. These are called the inert gases or the noble gases, you know that. And they will have octet configuration in the outermost shell. They will have very stable octet configuration. Then you have got something called representative of or normal elements. Okay, and representative or normal elements will just have the outermost shell incomplete. Outermost S or P subshell will be incompletely filled. Okay, so those are called normal elements. So the normal elements will be S block elements, P block elements, where they just have S and P subshell incomplete of the outermost shell. Okay, then you have got the transition elements. The here middle one, they're called transition elements. Okay, they are also called transition elements. Now why transition? You must know that that these are highly electropositive. Yes, these are electronegative. Okay, so in between highly electropositive, highly electronegative, in between lies these elements. Yes, they're called transition because they form a transition from highly electropositive to highly electronegative. They form a bridge kind of thing. That is why they are called transition elements. Okay, and transition elements will have incompletely filled D subshell. Okay, incompletely filled or unfilled D subshell. Okay, they are called transition elements. D block are transition elements. Then out here F block, they are called inner transition elements. They will have outermost 3 shells not filled. Okay, not completely filled. Outermost 3 shells incomplete. Okay, 2 shells incomplete, and for the normal 1 shell incomplete. Okay, that is S and P subshell is incomplete. So those are the names. Inner transition, this is also called inner transition elements. F block elements are also called inner transition elements. These are called, D block are called transition elements. Okay, then S and P block elements, they are also called normal elements or representative elements. Okay, you have to keep in mind. Okay, then after that you have got a little problem here. Okay, you know how to find these, no? I bet you have done it in class 10. Okay, but let's do it again. How to find the period, group number, and the block of elements. Okay, if you are given the atomic number, you can easily find out in which period they fall, in which group they fall, and in which block they fall. Okay, so how to find the period? You have to check the outermost shell. Yes, period, you know that period means the number of shells. Yes, so if you check the outermost shell, you'll easily find the period. Okay, for the block means SPD and F block. So you have to see the last element, the last electron, it enters to whichever subshell, that will be your block. If it enters to S subshell, it is S block. If it enters to P, that is P block, and so on. Okay, then finding the group, I have written out the for you. Okay, this will be of help. Okay, so just see, for group, okay, if it is S block, you'll have either 1 or 2. Okay, group 1 or group 2. Okay, I will just solve it, then you will understand. Now, first one out here, we are given an element A. Okay, and its atomic number is given 11. Okay, now we have to find out the period, the block, and the group. Okay, so let's see how to find out the period. Okay, so first you'll write the electronic configuration. 11, 1s2, 2s2, 2p6, 3s1. Now, how do you find out the period? How do you find out the period? You look at the outermost shell. Okay, which is the outermost shell? There's 1, there's 2, and there is 3. So, which is the outermost shell? 3. So, how many shells it will have? 3 shells. So, what is the period number? Period number is 3. Okay or not? You remember, no? If there is period number is 3, it will have 3 shells. So look at the outermost shell. This 3. Period is 3. Then block. The last electron enters which subshell? Last electron, have a look. S. So block is S block. Okay. Now group. Okay. Now group. How to find out the group? Look at the block. Look at the last electron entering to S subshell. S subshell. Okay. So it will either have 1 or 2 group. Yes, 1 or 2 group only. 1 or 2 group only. Yes. So out here, which one is it? S is entering to 1, just 1 electron. So the group will be group 1. Yes, alkali metals. Okay. Then the next one is here, 17 I am given. Atomic number 17 I am given. I am given element X whose atomic number is 17. Now to find out the period, block and group, I have to write the electronic configuration. So this is the electronic configuration of 17. 1s2, 2s2, 2p6, 3s2, 3p5. Yes, 6, 7, 8, 9, 10, 5, 6, 7, 17. The period, outermost shell. Which one is the outermost? 3. Have a look. So period is 3. Yes. Now block. The last electron goes to P. So P block. I hope you're getting it. Then group. Now how to find the group for P? Okay, I have written out here. For P block, the group will be 12 plus number of electrons in the P subshell. Okay, so P in the P subshell, last one, how many are there? 5. So you have to add 12 plus number of electrons in the P, 5. Okay, so how much is this? 12 plus 5, 5, 6, 7, 17. Okay, so let's check. 17. 17 is chlorine. Yes. Period we found out is 3. Have a look. It is 3. It is 3. Yes, it is 3. Yes. Then the group number is 17. Yes, it is 17. Yes. Then let's check this one also. 11. 11 is sodium. Have a look. Period is 3. Yes, we got it. S. S block. Group is 1. Group 1. Okay, so that is how we find out. Now, finally, we have got for nickel. Okay, I've given a D block here, example. Yes, so you write the electronic configuration. This is the electronic configuration. Period number. Okay, period number, outermost electron, which one is it? 3 is there. Then 4 is also there. Which one is it? 4. Period number is 4. Block is, last electron will enter D. Yes, so block is D block. And the group. Okay, so group, how to find out for D? If the last electron enters the D block, I've written out here, you have to do it like this. Okay, group 2 plus number of electrons in D subshell. So 2 plus, what is the number of electrons in D subshell out here? 8. Okay, so 8 plus 2, 8, 9, 10. Okay, we got 10. Let's check. Nickel, 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 nickel. Nickel is out here. How much did we find out? Period 4. Have a look, nickel. Period is 4. Okay. Then block. Of course, it is D block. Then group 10. Did we find group 10? Yes, we found out. Okay. Group 10. So that is how you find out. Okay. So I've given you a homework. Do this one. Okay. If you're given the atomic number 25, 16, 19, find out the period, block, and the group for these elements. Okay. So, then after that, there is something called finding the IUPAC nomenclature of elements greater than 100. Okay, whose atomic number? Atomic number, you know, Z, it is greater than 100. Okay, so we have to write the IUPAC nomenclature. Okay, it's given in the book here, page number 39. Okay, this one we are going to do. This one we are given the name of the elements. Okay, now let's see how to find out. First and foremost, you need to know this one. Okay, you need to memorize this. 0, it is nil. You write nil. And the symbol out here is N. 1 is un, U. 2 is bi, 3 is tri, 4 is not tetra, it is quad. Okay, quad, Q. Okay, why it is quad, why it is not written tetra is because tri, the symbol we have taken T. If you write tetra, it will be T again. Yes, that is why we have written quad, Q. Penta, pent, P, hex, H. Hex 7, hepta, we have not written hepta. Sept, we have written S. Oct, N, E. Okay, you memorize these and these are the symbols. Okay, now let's write. And when you write the name, you have to write EM at the end. Okay, so let's try to write the IUPAC nomenclature for atomic number 104. Okay, 1 is what? Un. 1 is un. 0 is what? Nil. Un, nil. Then 4 is what? What is 4? Quad. Q-U-A-D. Quad. Then let's write EM. I-U-M. EM. Okay, this is the name. Right? Un, nil, quad, EM. And if I write the symbol would be U, N, Q. Okay, this is the symbol. Easy as that. Only thing you have to do is you have to mark this up. Okay, mark it up, then easily you can do. Suppose if I do 100, 1, 1. Okay, 111. How do I write? 1 is what? Un. Un. Again 1. Un. Again 1. Un. Then I have to add EM. Easy as that. Yes. So its symbol is U. Symbol. Okay, another I can take is 102. Okay, 102. So 1 is what? Un. 0 is nil. Okay, then 2 is bi, bi, bi. Then you have to add EM, no? IUM. Okay, so instead of IUM, you just omit I because it already has I. BM, BIUM you can write. Or you can also write BIIUM. Okay, or this is better. Okay, sometimes they have written IIUM also, but okay, instead of 2 I's, you can write just 1 I. Okay, so this is how you do. For your homework, you would be doing 116, 118, and 107. This is your homework. Okay, refer your book. Without looking at the book, you do it. Okay, see, they're given. This is the symbol they have provided out there. Okay.